Hi, welcome to Module 2. Today we're going to be talking about incidence and prevalence. First, before we can talk about incidence and prevalence, though, we need to discuss a few key definitions that will be important for understanding the concepts of incidence and prevalence. So first, we're going to talk about ratios. A ratio is very simply just a quotient of any two numbers, so one number divided by another. An example of this would be 60 miles traveled per hour, or divided by an hour. That's a ratio. It's a very general term. It basically just includes any numeric expression that has a numerator and a denominator, so any fraction is a ratio. A proportion is a type of ratio. It is defined as a fractional component of a quantity. So this is when the numerator, the top number, is contained in the denominator, which is the bottom number. So an example of this would be 40% of residents own their own home. Say you have 100 people who live in a town, 40% of them own their own home, but 60% do not. Well, the 40% who own their own home, they're part of the 100 residents. So the numerator is contained within the denominator. A proportion always ranges from 0 to 1, or if you're looking at it in a percentage, from 0% to 100%. And again, a proportion is a type of. A rate is also a type of a ratio, but it's a change in one quantity to a change in another quantity. Almost always the denominator is some unit of time. So this could be days, hours, minutes, years, etc. Here are a couple of examples. Both of these are rates. Say that you're told that there are 9,000 new cases of, it should say, lung cancer per year. That's a rate. You have 9,000, and then the denominator is per year, 1 year. So that's per unit of time. But that's an absolute rate. We know that there are 9,000 new cases, but we don't know relative to what. So is that a lot or little? We can't tell. So often what's done with rates is that they're provided in relative terms. So the last bullet point that you see on the slide is a relative rate, 9,000 new lung cases per 100,000 people per year. So from this you can tell that 9% of the population, 9,000 divided by 100,000, are developing lung cancer. Here's an example for you. The number of children born prematurely in the state of Alabama in 2015 divided by the number of children born in Alabama in 2015. Is this a rate, a proportion, or a ratio? Well, it's definitely a ratio because it's one number divided by another, but it's also a proportion. This is because the number of children who were born prematurely in the state of Alabama, they're also part of the denominator. They're part of the number of children born in Alabama in general. So when the numerator is part of the denominator, that's a proportion. This leads us to incidence and prevalence. These are going to be typically rates, which is why it's important to understand the difference between proportions and rates. Incidence is a very important term in epidemiology. It is defined as the number of new cases of disease in the population during a period of interest. So new is the key word here. How many new cases are being diagnosed? For instance, maybe you want to study the number of diagnosed flu cases in a flu season. Incidence is very commonly used for acute conditions. This means things that are short term. So flu, you develop and you get over it in usually a week or less. That's an acute condition, as opposed to a condition that is chronic, like, say, muscular dystrophy. Once you develop it, you have it for the rest of your life. The other term that we're going to be talking about is prevalence. This is the number of persons in the population who have a disease at a given point in time. So it's not necessarily new cases, it's just the number of people who have the disease. it includes or reflects both incidence and duration. So if someone has cancer for 10 years, they would only be counted as an incident case one time, but because they have it for 10 years, they're counted as prevalent each year. An example would be the number of people with multiple sclerosis, MS, in a population. Again, this is more appropriate for conditions that are chronic or long-lasting. So this table is from your textbook, and it just shows some of the differences between prevalence and incidence. For prevalence, you can think of the cases, or think of cases like an outcome, a disease usually. The cases for prevalence are entities, they're people. So people have diabetes or MS or muscular dystrophy. Whereas with incidence, it's more an event. You get the flu. The population for prevalence, people are at risk to be a case, whereas with incidence, they are at risk to become a case. The key words there are underlined. Become with incidence really reflects the transient nature of these conditions. They come and they go. So you can become a case and then you can revert back to not being a case anymore, like with the flu. Prevalence is static in time, meaning that there's long-lasting duration of these diseases. And then incidence is dynamic, comes and goes. Prevalence is typically used for planning. If we know the prevalence of, say, type 2 diabetes, we can know what kind of health care needs to be provided, how many physicians are needed in each portion of the country or the state or the city, what kind of infrastructure demands are going to be in place based on the prevalence of certain diseases, whereas incidence is typically used for etiologic research. This means basically causes. So if we know the incidence of flu in a certain area, that can help us understand what causes flu to spread and maybe even how to prevent that. Next, let's talk about incidence and prevalence rates. Remember, we've defined rates already. With incidence and prevalence rates, these are generally going to be expressed as a percentage of the population. So the rate would be the number of cases divided by the size of the population. So for the incidence rate, let's go back to the flu example. Let's say we want to know the incidence rate for flu for students living in the Sanford dorms. In one flu season, there are 126 students who live in the dorms who are diagnosed with the flu. 953 total students actually live in the dorms. 126 divided by 953 is 13.22%. That means that the incidence rate is 13.22%, and that reflects that 13.22% of the students who lived in the dorms contracted the flu during the time of the study. The prevalence rate is calculated basically the same way, but again, it just reflects existing cases rather than new cases. So the prevalence rate for colon cancer is the example that we'll use. Let's say that 937,385 people live in Birmingham, and 1,257 of them have colon cancer. If we divide the numerator by the denominator, we come up with 0.0013%. That percentage of Birmingham residents have colon cancer. Another way to express this that can be a little bit more meaningful is you can express it in per 1,000 or per 100,000. In this case, 1.3 in 1,000 people have colon cancer. So just over 1 in every 1,000 people living in Birmingham have colon cancer. That can be a little bit easier to wrap them around. Another concept that we need to discuss is cumulative incidence. This is going to be abbreviated CI. So this is used when the population that's at risk of a certain disease or condition varies over time. So with the flu example, once you get the flu within a season, you're no longer at risk of getting it again because your body becomes immune. Mathematically, what this means is that the denominator changes. The number of people that are able to contract the flu is changing. So cumulative incidence accounts for that, and it's a way to get a better idea of the true risk of getting a disease. Because if you've already had the flu, you're not at risk anymore. So let's use a different example. There's a viral disease called hand, foot, and mouth disease that's common in young children. Frequently, there are breakouts at preschools. So let's say there's a breakout at preschool A. In October, 12 of the 75 children who are enrolled get hand, foot, and mouth. That is an incidence rate of 16%. In November, 8 more children get hand, foot, mouth. So now 20 out of the 75 have had hand, foot, and mouth this year. That's 26.7%. But that's not really the true risk of getting the disease in November, because the 12 children who had it in October recover and are no longer at risk. So what happens is that you subtract the 12 children who developed the disease in October from the denominator. So 8 divided by 75 minus 12 comes out to 12.7%. So the risk of a child getting hand, foot, and mouth in November was 12.7%, not 26.7%. And that is reflected in the calculation for cumulative incidence, not with the incidence rate. So if you wanted to know the risk for a child to get the disease in December, you would use a denominator of 55. That comes from 75 of the children, the number of children at the preschool, subtract the 12 that got it in October and the 8 that got it in November, and you come up with 55. Next is incidence density. This is another measure of incidence, but it's slightly different. It takes into account the time that someone was exposed to a risk factor. So remember that cumulative incidence is the number of new cases divided by the number at risk. Incidence density is different because it's the new cases divided by what we call the population time. It's the amount of time that individuals in the population are exposed to risk. So let's give an example. If we go back to the hand, foot, and mouth preschool example, let's say 3 new children enroll in December. Well, those children have not been exposed the same length of time that all of the original 75 children have been. So to account for these 3, we need to do some sort of different calculation. That's where incidence density comes into. This is an important question to think about. Does high prevalence indicate high risk? The answer is it can, but not always. The reason is that sometimes conditions are survived over the long haul. Therefore, the prevalence of the condition is actually very high. A lot of people have it, but that doesn't necessarily mean people are constantly developing the disease. So you could have high prevalence but not high incidence. For instance, let's say Birmingham has a high prevalence of coronary heart disease. That doesn't necessarily mean that something about living in Birmingham is causing people to get coronary heart disease. It could be that the medical treatment here is better for coronary heart disease. It could be that people move here for some reason related to coronary heart disease. There are a lot of potential explanations that are explained by reasons other than some risk factor due to living in Birmingham. So the prevalence rate can increase because people are surviving. What diseases that used to kill people are now being survived longer, so that causes the prevalence rate to go up, but the incidence rate actually stays the same. Let's compare cumulative incidence and incidence density using an example. This is from a published paper that was looking at rates of breast cancer in a couple of different studies. So you can see from the quote on the slide, this paper found substantially different occurrence rates of breast cancer, 6.7 per 1,000 in a study called the nurses cohort, and 18.2 per thousand in a different study called the Incidence cohort. So one study found about a 3 times higher rate of breast cancer than the other. At first glance, that's very alarming, and you would want to investigate what might be going on to explain this. But upon further examination in the nurses' study, what they did is they divided the 601 cases of breast cancer divided by the population, which was almost 90,000 women. They studied them over 4 years. So the cumulative incidence is 6.7 per thousand. You don't need to worry about how to calculate incidence density. Just know that the incidence density calculation, once they accounted for the 4 years of follow-up for all almost 90,000 women, comes out to 1.68 per 1,000 women years. So that means that if one woman was followed for 2 years and another was followed for 4 years, that was accounted for. In the Incidence study, they took 121 cases of breast cancer divided by just over 7,000 women who were followed for 10 years. And the cumulative incidence was 16.8. But when they calculated the incidence density, because remember they followed these women for 10 years, whereas the other study only followed them for 4, the incidence density was 1.68. What this means is that because of the different amount of follow-up, the cumulative incidences were different, but the incidence densities were not. So there really isn't a difference in these 2 examples. So the moral is that it's a little bit dangerous to compare cumulative incidence if the follow-up was different. You need to make sure you think about how long the was. Kind of along those same lines, to know the true risk of a disease, you have to have a denominator. So an example would be, say a doctor says he's seen 100 runners in the past year that have iliotibial band syndrome. It's a pain in the outer portion of the upper leg. It's pretty common in runners. So if a doctor says, yeah, I've seen 100 runners in the past year with IT band syndrome, does that mean this is a common condition? Well, the answer based on that information alone is you can't tell. It depends. If the physician has seen 150 runners in the past year and 100 of them have the IT band syndrome, then yes, the incidence is very high. But if you've seen 10,000 runners, then the incidence is very low. It just depends on the denominator. So it's a very important point. You have to have some total number to compare to, a denominator, in order to make any claims about. The rest of the time I'm going to let you scroll through these practice questions. The answers are on the screen, and you have access to the slides as well. I'm not going to read these for you, but you can hopefully affirm what you've learned about incidence and prevalence based on these 7 practice questions. And the last thing I want to talk about is today your discussion number 1 is due. You will follow the directions that are posted on Moodle, make your own initial post, make sure that you comment on the post of at least 2 other individuals in the class, and note that the forum closes tomorrow at 8 p.m.